Hi students, welcome to the video lecture 7 of heat exchangers. The today's class we are going to study the topic effectiveness NTU relation for counterflow heat exchanger. So already while deriving the equation for LMTD for counterflow heat exchanger, already we have derived this equation. So let me start from that equation only. So yeah, log of Th2 minus Tc1 divided by Th1 minus Tc2 is equals to minus U into A in the bracket 1 divided by Mh into Cph minus 1 divided by Mc into Cpc bracket complete. Same equation I have written here, log of Th2 minus Tc1 divided by log Th1 minus Tc2 bracket complete. This will be equals to minus U into A in the bracket 1 divided by this Mh into Cph is replaced by 1 divided by Ch minus 1 divided by this Mc into Cpc is replaced by 1 divided by Cc. So here also I am assuming any one of the fluid as the minimum fluid, and then definitely other fluid will be maximum fluid. That means here Ch I have assumed it is less than the value of Cc. So when Ch value is less than Cc, then definitely Ch will be equals to C minimum and Cc will be equals to C maximum. The same equation I will write here, log of Th2 minus Tc1 divided by Th1 minus Tc2. This will be equals to minus U into A. Here I have taken 1 divided by Ch as common. How we have taken in the previous effectiveness for parallel flow heat exchanger. Here also I will take 1 divided by Ch as common. And I will take 1 divided by Ch as common, and then in the bracket it will be 1 minus Ch divided by C of C. So the same equation I have written, minus U into A. When I taken 1 divided by Ch as common, C1 divided by Ch is nothing but Ch is C minimum. Directly I will write here C minimum in the bracket 1 minus Ch divided by Cc. That will be C minimum divided by C of maximum. So if I will remove this log term, then the equation remains Th2 minus Tc1 divided by Th1 minus Tc2 is equals to exponential form of this equation. Whereas exponential of minus UA divided by C of minimum in the bracket 1 minus C minimum divided by C maximum. So this UA divided by C minimum is nothing but NTU, where NTU is given by this formula in the bracket 1 minus C minimum divided by C maximum is nothing but capacity ratio C. So let me call this equation as equation 1. So these values already, the values are calculated by the formula effectiveness of the heat exchanger. That is, effectiveness of the heat exchanger epsilon is given by Q divided by Q maximum. From that equation already these values Th2 value and this Tc2 values already we have calculated while deriving the effectiveness of the parallel flow heat exchanger. The same values I am going to put these Th2 value and Tc2 value in equation 1. So here Th2. So Th2 value is given by Th1 minus epsilon into C minimum Th1 minus Tc1 divided by C of H. So in this equation, in this here, we have already assumed Ch as C minimum value. So C minimum gets cancels. So my equation will be Th1 minus epsilon. This gets cancels. So this will be Th1 minus Tc1. So minus Tc1 as it is. Minus Tc1 as it is. Equation 1 divided by Th1. Th1 I have kept as it is minus this Tc2 value. This Tc2 value I will substitute from this minus of epsilon into C minimum divided by Cc. This is where Cc is C maximum in this equation. So C minimum divided by C maximum is nothing but capacity ratio, which is indicated by C only. So this equation will be epsilon into C in the bracket Th1 minus Tc1 minus Tc1. So this is the value of Tc2. I have substituted here Th1 minus Tc2. So I have substituted this Th2 value and Tc2 value in equation 1 here. In equation 1 I have substituted both these values. So Th2 is given by this equation minus Tc1 as it is. So Th1. So Th1 I have kept as it is minus Tc2. Tc2 value is this. So this will be equals to exponential of minus NTU in the bracket 1 minus C. Equation remains as it is. So now next, TH1 minus epsilon of TH1 minus TC1 divided by TH1 minus epsilon into C TH1 minus TC1 this will be equals to exponential of this term. So TH1 minus TC1, it is common on in both numerator and the denominator. So I have taken TH1 minus TC1 common. So this equation will be 1 minus of epsilon. So if I will solve this equation, I am going to get this equation in this form only. So here also TH1 minus TC1 I have taken common. So this equation will be 1 minus epsilon into C equals to exponential of this term, where NTU is replaced by N. Equation remains as it is only. TH1 gets cancels. So this equation will be 1 minus of epsilon divided by 1 minus epsilon into C. This will be equals to this equation, exponential of minus N in the bracket 1 minus C, bracket complete. So here 1 minus epsilon, this will be equals to this, and this I have cross multiplied it because I want to calculate the value of effectiveness. So 1 minus epsilon, this will be equals to this equation and this equation cross multiplied, 1 minus epsilon into C into exponential of minus N in the bracket 1 minus C. So 1 minus epsilon equals 2. So I have simplified both these equations here. So 1 into exponential of this term, this will be exponential of minus N in the bracket 1 minus C minus this and this term, minus epsilon into C into this term. Now I have taken this term to the left side, that is 1 minus exponential of minus N in the bracket 1 minus C. This term I have taken left side, and this equation I have taken it to the right side. So this will be 1 minus exponential of minus N in the bracket 1 minus C. This will be equals to exponential of, when I take this term to the right side, then this will be plus epsilon minus, the equation remains as it is here, this equation. So 1 minus exponential of this term same, this will be equals to, so here again epsilon I will take common. So here in the bracket it will be 1 minus C of exponential of minus N in the bracket 1 minus C. So finally if I will take this effectiveness term outside, then my equation will be 1 minus exponential of minus N in the bracket 1 minus C divided by 1 minus C the bracket exponential of minus N in the bracket 1 minus C. So this is my final expression for the effectiveness of the heat exchanger. So these notes I will be putting for you in your WhatsApp group. You can go through the notes. So now if I will assume CH is lesser than the CC, that means CC is greater than CH, then here CH becomes C maximum, CC becomes C minimum. So in this condition also, if I will substitute the values, so I am going to get the effectiveness for this counterflow heat exchanger in this form only. That means if I will assume any one of the fluid as minimum fluid and the other fluid as the maximum fluid, in both the cases we are going to get the same expression. So this is my final expression for the effectiveness for the counterflow heat exchanger. So here are also we'll study some two special cases. If the problem is based on a condenser or a boiler, so here effectiveness is given by this formula. So when CH value is equals to CC value, that is C minimum is equals to C maximum, that means capacity ratio is equals to 1, then effectiveness is calculated by this formula, where NTU divided equals to NTU divided by 1 plus NTU, or effectiveness is given by N divided by 1 plus N, where N is nothing but NTU. This C value equals to 1, I have substituted in this equation only. I have substituted the equation in here only, then we have got these values, where effectiveness is equals to NTU divided by 1 plus NTU. So this completes the theory part of the heat exchanger. So in the next class we will study the varieties of problems.